The James Webb Space Telescope has already transformed astronomy. It has looked deeper into the universe than any telescope before it. It has revealed ancient galaxies, studied distant worlds, and peered through clouds of cosmic dust. But now, James Webb may have achieved something even more remarkable. For the very first time, it has allowed scientists to study the surface of a rocky planet beyond our solar system. Not its atmosphere, not just its orbit, but the ground beneath an alien sky. That may not sound revolutionary, but there has always been one enormous problem. We have discovered more than 5,000 exoplanets, thousands of completely different worlds, but for almost all of them, we've only known a few numbers. Their size, their mass, their temperature. Imagine discovering thousands of islands without ever seeing the beaches, without knowing whether they're covered by forests, volcanoes, or deserts. That has been exoplanet science for decades. We've been finding planets, but we couldn't truly explore them until now. Because this discovery isn't just about one planet, it's the beginning of studying alien geology. It's the moment exoplanets begin to feel like real places. The planet is called LHS 3844b, a rocky super-Earth orbiting a small red dwarf star. It lies around 48 light-years away, close enough for James Webb to study, yet still unimaginably distant. Its star isn't bright yellow like our Sun. Instead, imagine looking up at a giant glowing red lantern, a deep crimson light. But there is another problem. Normally, scientists cannot study the surface of rocky exoplanets. Why? Because their atmospheres get in the way. Imagine trying to study a mountain, while thick fog covers every inch of it. You know the mountain exists. You know roughly how large it is, but every detail remains hidden. Most rocky exoplanets are exactly like that. The atmosphere hides everything below, but LHS 3844b is different. It has almost no atmosphere at all, no clouds, no weather, no thick blanket of gas. Its rocky surface lies completely exposed, and for James Webb, that changed everything. But wait, even without an atmosphere, James Webb still can't simply take a photograph of the planet. It's far too small, far too distant. So how do you study a world you cannot actually see? The answer is heat. Everything warm glows in a visible infrared light. Your body, a campfire, fresh lava, even a rock sitting beneath a star. James Webb doesn't just see light, it sees heat. It observed LHS 3844b as it disappeared behind its star, measuring tiny changes in infrared light, again and again and again. Then astronomers split that light into thousands of wavelengths, searching for tiny chemical fingerprints, almost like detectives trying to identify a person from a single fingerprint. The fingerprints pointed towards something unexpected. Basalt, dark volcanic rock, the same material found across Earth's ocean floor and inside ancient lava fields. Imagine standing on this alien world. Beneath your feet, endless plains of black volcanic rock. Around you, a silent landscape shaped by ancient eruptions. Above you, a giant crimson star never moves. Because this planet is tidally locked, one side permanently faces its star, the other never sees daylight. One hemisphere burns beneath endless noon, the other remains frozen in eternal light. But here's what makes this discovery extraordinary. Scientists didn't simply learn something about one planet, they proved something far bigger. For decades, exoplanets were little more than entries in a catalog. A name, a mass, a radius. Interesting, but distant. Now, for the first time, we can begin asking geological questions. What rocks are there? Where are there volcanoes? Is the surface changing? Could tectonic plates exist? This is exactly what happened with Mars. First, we discovered it. Then, we mapped it. Then, we explored it. And today, James Webb has taken the very first step toward doing the same for worlds dozens of light years away. Today, we've identified volcanic rock. Tomorrow, perhaps we'll detect active lava flows. One day, continents, oceans, maybe even weather on truly Earth-like worlds, and eventually, perhaps evidence that another planet is actually alive. Every great journey begins with a single step. For humanity, this may be the first real step toward exploring worlds we may never physically visit, because the universe isn't just revealing new planets anymore, it's beginning to reveal their stories. And this may be only the beginning.